Hey guys, we are back looking at converting, in this video, rectangular equations to polar equations and polar equations to rectangular equations. So you probably have experience already converting polar coordinates to rectangular coordinates and vice versa, so we should be familiar with these conversion equations that are going to be the tool to use for converting equations. So the idea here, why we would want to convert a rectangular equation to a polar equation, is sometimes we have a polar equation that is much cleaner looking, much simpler looking than a rectangular equation. And the opposite is true as well. Sometimes we have a rectangular equation that is much simpler than a polar equation in terms of appearance. Okay, so I'm going to teach you how you can use these conversion equations to go from rectangular to polar and polar to rectangular. Let's begin. All right, so looking at this equation, r equals 5. So we want to convert it to rectangular. So when we're converting to rectangular, we have to keep in mind that we're going to be working with often these two conversion tools. All right. Now, that's not always the case. Sometimes we use these two, but I say that because x squared plus y squared, I can get x squared plus y squared into an equation if I had an r squared. So often, one of the very first things we do, if I have r, is we're going to square both sides so that I have r squared, so I can substitute in x squared plus y squared. So let's try that and see what we get. So we're going to square both sides, which gives us r squared and then 25. So now we did that, so we could substitute in x squared plus y squared. And there you go. We went from polar, where it's in terms of radius, and there's no theta here, but it's in polar, and we converted it completely to rectangular x and y. And yes, you might be wondering, do I have to solve and say y equals? Not always. Not always, and this is a case where you don't need to, because this is an equation of a circle. So this is the circle equation with a radius of 5 centered at 0, 0. Okay, now what we know from this, before I move to the next problem, we know that this is a circle equation in the rectangular system. X squared plus y squared equals radius squared. So we see that if I graphed r equals 5 in the polar system, r equals 5, or r equals any constant, that is a circle of this radius. Okay? So circles in the polar system are very, very clean, very, very simple. I mean, really, rectangular's not that bad either. But let's look at the next one. Keep in mind, guys, if you do not have these written down, write your conversion factors down now. So let's look at the next problem. Convert to rectangular. R equals 7 secant theta. So none of our conversion equations deal with secant. Well, we can convert secant. We can rewrite secant as 1 over cosine. All right. So 1 over cosine, again, I can't really work much with that. If I square this side, and this side, yes, I get x squared plus y squared, but nothing will help me here. Having a secant squared, or that's not going to help me at all. So rather than squaring both sides in this approach, because it would not help me on the right, is we're going to multiply both sides by cosine. So I multiply both sides by cosine, we get cosine of theta times r equals just 7, because the idea was to cancel the cosine on the right. Now, looking at this, r cosine, we can replace that r cosine, and we can replace with x. And there you go. R cosine is equal to x. So a radius, so r equals 7 secant theta. That polar equation really comes down to when we graph it as a vertical line, hence x equals, through x equals 7. Okay, so maybe if I had 7 cosecant theta, maybe that's a horizontal line? Well, I guess you can try that out yourself. So let's look at the next equation. So if I had, not that one, not yet at least. So if I had convert to rectangular. So r equals 4 cosine theta, 8 sine theta. So in this problem, what we can say, well, okay, if I squared both sides, so thinking that, asking yourself if you can square both sides, that's going to be a very great tool to begin. So if I square both sides, yes, we get r squared, I can replace that. If I multiply this side by, oh, okay, I've been saying this a little wrong. In the first example, yes, we squared both sides. Here, I'm going to multiply both sides by r. That's what I'm doing here. So, okay. So we're going to multiply both sides by r. So we would get r squared. So not really squaring both sides, but multiplying both sides by r. All right, yes, we'll get r squared. We can replace that. And notice on this side, we're going to get r cosine, r sine, which we can replace. So we have r squared equals 4r cosine theta plus 8r sine theta. Again, that was our move, because doing that to both sides allowed us to replace something on both sides of the equation. I don't want to do something to both sides to only work with one side. Okay? So we have r squared. We can replace that with x squared plus y squared. R cosine we can replace with x. R sine we can replace with y. All right. So we're not quite done yet. So I'm going to bring all of my terms to the left side. So we have x squared minus 4x plus y squared and minus 8y. Okay. Now, this technique that I'm about to use, if we don't use it a lot, we tend to forget it. So my goal here is I'm thinking that this is going to come down to where I have a circle. Just because a lot of polar equations end up being some type of circle. So what I'm going to do here is I'm going to complete the square. I'm going to complete the square for both of my groups, my x group and my y group. I'm going to put a link here on the screen just so you can go back and possibly take a moment to review completing the square. We don't have time to completely go through and teaching it here. But in completing the square, negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So we get x squared minus 4x plus 4. We completed that square. And then negative 8 divided by 2 is negative 4. Negative 4 squared is 16. Okay. So since I placed in 2 new terms, I have to place them on the other side as well. Okay, so we have that. We did that so that I can condense both of these groups. So x squared minus 4x plus 4 condenses to x minus 2. Y squared minus 8y plus 16 condenses to y minus 4. Again, reviewing completing the square would help you with all of this. And then we get 20. So now we have our equation. But you can see now what r equals 4 cosine plus 8 sine, what we get. So we get, by multiplying both sides by r, we get a circle equation with radius square root of 20 centered at positive 2, positive 4. All right. So with converting equations, it's just a matter of getting experience, practicing problems, and just gaining experience here. All right, so looking at our last example, converting to rectangular. So we have this problem. R equals 4 over 3 cosine theta plus sine theta. Now, when we did not have a fraction, previous example, I multiplied both sides by r, which gave me r squared, and then r cosine, r sine. All right. If I were to multiply both sides by r, I would get r squared, but the r on the right side would only go to the 4. So recognizing that that's not the approach we're going to take. If I square both sides, yes, we'll get r squared, which is okay. But when I square the right side, it's going to give us a mess. Okay? So we did something in the second example where I had a fraction, and I wanted to remove the fraction by multiplying both sides by that. So we're going to multiply both sides of this equation by our denominator. So when I do that to this right side, they'll cancel, giving us 4. And the left side will become r times 3 cosine theta plus sine theta. And then the right side is again just 4. So let's distribute this r, 3r cosine plus r sine equals 4. Oh, r cosine, r sine, we love seeing that because we can just write 3x, and then this is a y equals 4, guys. There's no squared component, meaning this is not a circle, so we didn't square r. Understand that. So we're not going to have a circle here. So we have 3x plus y, so if I solved for y, maybe we already know what this is. This is a linear function. So this is a prime example of a linear equation that looks rather simple, but when converted to a polar, it loses that simplicity appearance. So the advantages of disadvantages of each. So linear function with this problem. Maybe when I have r equals and then a fraction like this, maybe it always comes out to a linear function. I guess with more practice we'll find out. So moving on. So now, actually before we move on, I want to say here, I'm going to put a link here on the screen. I have one more polar equation that we convert to rectangular. It is quite hefty. So I'm going to put it as an extension video. When you feel confident with just these 4 polar examples, take a moment and look at that extension, okay? It's one example converting a simple polar equation, and you get a really complex rectangular equation. So take a moment now, the link on the screen, go and check that out. So ending, let's convert some rectangular equations to polar. These turn out to be a lot simpler, mainly because what we're using to substitute in. So here, converting rectangular to polar, all we need is an x, and I can substitute in r cosine theta. That's it. So if I have this, let's see. So 2, okay, r cosine theta minus y, so that's r sine theta, all right, equals 4. Fine. So we're trying to get r equals. That's the goal here with polar, is we want to get r equals. So as both terms have an r, so we're going to factor that r out. Okay. So great, because this is one group, so I can divide both sides by that. We're going to divide both sides by that grouping. Okay, which gives us a polar equation of 4 divided by 2 cosine theta minus sine theta. Now, I said just in the previous example, linear equation. Oh, a fraction of a sort. There we go. All right, so let's look at the next 2. So converting to polar, again, we're going to be using, if I have an x, we're going to use r cosine. If I have an y, we're going to use r sine. If I have x squared plus y squared, we're going to replace it with r squared. So I have x squared plus y squared, we're going to replace this grouping with r squared. Okay, we're trying to get just r. So when we square root both sides, we get r equals, yes, we get positive negative 6, but when we look at graphing points, we know how negative 6 and positive 6 really represent the same circle. It's just the negative 6 takes us through the pole and to the other side, but we get a result of the same graph with negative 6 and positive 6. Here, we just write positive, r equals positive 6. Rectangular to polar, bam, we are done. Last problem, guys, let's do this. So we have a circle, but it's not as straightforward. So we're gonna factor both of these out. Actually, we're gonna multiply both of these out. So x minus 4 squared, that's x minus 4 times x minus 4. So x squared minus 8x plus 16. Okay, y plus 1 times y plus 1. Y squared plus 2y plus 1. All that equals 17. All right, so I'm going to rearrange some things. So x squared plus y squared, and bring that together. Minus 8x, okay, and plus 2y. Let's go ahead and subtract 16 and 1 to the other side. It's almost as if this problem was made to come out this way. We get 0. Okay, so now we're going to substitute some things in. X squared plus y squared, we get r squared. And then we have, let's see, we have minus 8 r cosine of theta plus 2y, that's 2r sine theta. Okay, equals 0. Perfect, fine, that's okay. So now with this, I'm going to move this group to the right side. So it gives us r squared equals positive 8 r cosine theta minus 2 r sine theta. I can divide. Now you might be wondering, am I going to square root here? Well, you can square root, but it's going to get a little ugly because the goal with getting polar equations is that you have r equals and then something in terms of only theta. So if I took the square root of both sides, I would still have an r on both sides. So what we can do, guys and ladies, is why not just divide by r? Divide everything by r. If I do something to one side, I have to do the other side. So that gives us r equals 8 cosine theta minus 2 sine theta. Hey, there we go, we're done. I believe there's an example where we started with something like this. It should have been the third example in this video. So in the third example, we started with something like this, and I remember I said square both sides, and I was mistaken. Remember how I said multiply both sides by r squared, or sorry, by r? If I have this, you can see how the third example is simply this example, just in reverse. Okay, so if I start here, we multiply both sides by r. And you can see where we go from the top. All right, so best of luck. Just really get more practice. It takes confidence to do these problems, knowing how to use our conversion equations. Practice, 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 guys. And as we continue here, we're going to start looking at how do we graph these polar equations. Okay, good luck again, and I'll see you in the next video.